So welcome everyone, wherever you're watching from in the world. I'm excited to welcome you to the latest event for the AWS South Wales user group here in the UK. We're doing something slightly different this time in that we're focusing an entire meetup just on a single AWS service. And it's a hugely important one, which is Amazon EventBridge. So I remember, I think it was 2019 in Serverless Days London, Chris Munns was on stage talking about how Lambda came to be, talking about how events can trigger Lambda, the concept of events and event-driven architecture. And then he introduced this new AWS service that had just been announced, which is Amazon EventBridge. And since then, it's been the cornerstone of a number of event-driven architectures. So who better to tell us more about this than some of the leading experts in the use of EventBridge in the world? So that's why I'm delighted that we've got here today David Boyne, Luke Van Donkersgoed, and Sheen Brizzles. So the format of the event is that each one is going to come on and give a little talk about one of the features or some of the capabilities about EventBridge that they really like. And at the end, we'll bring everyone together where we'll ask questions of them as a panel. So the big ask for those watching on YouTube is to drop your questions in the chat, and we'll make sure then that we get them answered. So before we start the talks, I'd like to introduce Jim Carney from Mobilize, who are the sponsors of the user group and have been since day one, to say a few words. So over to you, Jim.
Yeah, thanks, Matt. Hello, everybody. Thanks for joining us this evening. Should be a great event. Really looking forward to the content. This is obviously a virtual meetup. So normally when we meet in person, we sponsor the event by providing food and drinks for everybody. But we can't do that, unfortunately, right now because it's virtual. So what we've been doing on these virtual meetups is providing free AWS certification vouchers. So we've got a couple to give away tonight, whether you're looking to do a CP, associate, specialist, or pro. You can put your name in a virtual hat, and potentially get a voucher. So to do that, we'll put the email address in the chat box as well, but it's vouchers@mobilize.cloud, mobilise.cloud. If you pop your details in there, tell us which level you're going for so we can issue a cert. We'll pick out a couple of random and hand them out. Just so you know, GDPR rules apply. So by putting your name into this inbox, there is zero danger of you being put onto a CRM system and us trying to sell you anything. So just put that out there. So please get involved. As I said, the vouchers are fairly pricey. It's a nice little prize to have. They're valid for 12 months, so it's worth having and sitting on just in case you're not ready for a cert just right now. That's vouchers@mobilise.cloud. Thanks, Matt, and everybody enjoy the evening. Cheers.
Cheers. Thanks, Jim. So now I'm delighted to welcome Dave Boyne.
Hello. Hi, Matt. How you doing?
Hi, how's it going?
Yeah, very good. How are you?
Yeah, good. So yeah, looking forward to giving you a talk now. So have you got anything you'd like to screen to share?
Yeah, I'll just set that up now. This is the one. Cool. You can see that? Great. Cool. I'll start then if that's okay. Yeah. Okay, so hi everyone, I'm Dave Boyne. So probably if you haven't seen me on Twitter, you can find me at Boyney123. I tweet a lot about kind of event architectures, mainly around Amazon EventBridge. Kind of introduced to it a couple of years ago. Done various different tools that you can find online, different developer tools, and kind of just spent a lot of time kind of diving deep into EventBridge. And just kind of using it for business. And I think the thing I fell in love with EventBridge was how fast you can get business value to your customers and how easy it is to, in a serverless world, create this architecture that is kind of decoupled. And you really start to see the value of that. As part of that, I was asked to kind of join tonight to give you a talk. And I was kind of thinking about what could I bring and what could I talk about? And it's something actually I've been looking a lot into at the moment, which is this idea of event design, right? And how event design can actually impact our systems without us kind of knowing it, right? Consciously or subconsciously. and how I believe event design, the events, the payloads themselves have a huge impact in what we actually do with Amazon EventBridge. So what we'll cover in this talk is the following: how event design can impact our architecture, different event patterns to think about and consider in the trade-offs of them, and then a summary, and then some resources at the end to do some further reading yourself. And there is a pasta dish on the right because I forgot to take it out of the presentation, but I did have pasta for dinner, but it wasn't anything like that, unfortunately. So I'm going to tell you a story, actually, and the story is called The Event Designer because I'm not creative enough to think of anything else. And this is actually based on true events. It's actually based on similar situations I had with Amazon EventBridge when I was using it, and what I saw over the kind of years of using it. Excuse me. Also, we have COVID in the house, so I will be coughing every so often. So sorry for that. So let's get started, right? So the story begins with something like this. So we have let's say for whatever reason, we have created a simple API here. We have an API gateway talking to a Lambda function into a DynamoDB table. Now, there are 100 ways of doing this with serverless, as many of you know. But let's say this is what we've got so far. We have an order service that we can create orders, get orders, update orders, and whatever else we want to do. Now, the product owner comes in one day and tells us, when an order is created, we want to generate an invoice for the customer, okay? Now, with our hats on, we start thinking about microservices and how we can kind of decouple all of this from the order service. So we decide to create something. We decide to create this thing called this invoice service, right? And again, it's got its own tables, functions, or whatever. Again, there are hundreds of ways of doing this. And then we connect the order service to this invoice service, and we say, okay, well, maybe I can get access straight to the Dynamo table, or maybe I can invoke this somehow, right? And then we start thinking, this is a bit of a bad practice because we've got the synchronous chain going on. For example, in this example, the order service would fail if the invoice service was to fail. And then we've been reading around online, and we've heard of Amazon EventBridge. We heard of event-driven architectures and asynchronous calls. So we decide as a team to use EventBridge, okay? And we create and we publish our first event. And our first event is called Order Created, right? Simple, nice, simple event. And we set up a rule and we set up a target to this invoice service that can do its job. So simple flow, order service publishes the event, does its job, publishes the event, and notifies downstream services of all this stuff going on. Now, the order service says, okay, what kind of data do we need to send? So they decide to send an order ID and a user ID to the invoice service. And the order service are kind of celebrating. They're like, yeah, we've done all our jobs, and that's all pretty cool. And the invoice service says, thank you very much. You've done your job. We now know what we need to do. And imagine this could be two separate teams. It could be the same team, whatever else. But we've got our event. So if we go into the details of invoice service and see what happens, you start to see a pattern emerge here, right? But for the invoice service to need to function, it needs to get data about the user. It needs to get data about the order, because the event itself isn't very useful. The notification was useful, but the data inside the event wasn't that useful in this particular case. So anyway, we talk to the user service, talk to the order service, and we're happy. The invoice service has done its job. We're delivering value to customers, and everyone can sleep at night, right? And we're happy. We've got our first path to this event architecture, and everything's looking awesome. And then, as SpongeBob would say, 1 week later, my kids love that, SpongeBob SquarePants. So the product owner will come along and say something like this: when an order is created, let's send users an email. Okay. When you think about when you're working on a product team and you think about your requirements, it's quite often that your requirements may come in this kind of asynchronous kind of manner. When something happens, we want to do something, right? And this is where event architectures, especially like EventBridge, can really help you quickly get that value. And that's what I've seen in the past. So to give you an example here, we piggyback off this order created event. We create a new service. And again, there's different ways of doing this, but let's just say for whatever reason, it was a Lambda talking to the email provider. and we get the value that we need. We don't need to talk to the order service anymore. We can just do what we need to do. Again, the payload hasn't changed. We've got the order ID and the user ID there in the middle. So what happens here is we have the same pattern again. We talk to the user service and we talk to the order service to get the information that we need to send the email, okay? And then as time goes on, we create more targets, more rules, and more kind of downstream services to our events. And when you look at this from this diagram, this picture, you might be thinking, okay, we've achieved our decoupling of all our services using EventBridge, and like times this by 10 and times this by 100 when you've got hundreds of events and different services, right? You kind of think, okay, we've got this pattern emerging. We kind of feel decoupled, but subconsciously or consciously, we have done something accidentally, right? We've accidentally created coupling in our downstream services. And this is kind of what is definitely what happened to me at the start when I was using EventBridge, is not paying enough attention to the payload and the event itself, because these are the kind of side effects that you may see. So the invoice at the top, we have the invoice service and the email and the internal service, all requesting data from the other kind of services and the user and the order service. So we're increasing the load there, right? And when I start thinking about this, when I was kind of writing, I'm thinking a lot about this kind of space at the moment, especially when writing this presentation. I started thinking about how the design of our events, especially when you think about Amazon EventBridge or any kind of EDA system, the design of our events have an impact in our architecture, right? And I don't think we speak about that enough, is what goes into our payloads have effect on the downstream services that need to operate. And what I'm talking about here particularly is something called a notification event. And you may, if you Google this stuff, you may see these may be called thin events. And the whole idea with this is that the data in the event is quite minimal. So on the left, we have the order ID and the user ID and some various AWS properties there. And it's kind of does its job. It notifies the system that something has happened. Now there are trade-offs, right? There are trade-offs with all this stuff, with everything that we do. We have the good stuff here is the simple contracts. And what I mean by contracts, this is the contract between your producer and your consumers, right? When we have APIs, we have contracts between the API and the consumers, and if we make breaking changes in APIs, we may break systems out there. So it's the same kind of concept, I think, here, which is we have contracts between who's consuming our events. But if the event itself is simple, then we have less chance of breaking contracts in the future. Another reason why you may use this kind of event is when you see is for like real-time data. So if your downstream services need real-time data, there is no problem getting that information, right? There's no problem making the request to get the information. But as long as you're doing that consciously, and what I find with this pattern is with this particular event, is we are forcing downstream services to go get extra information because the information is not already there in the event, okay? And typically a good thing here is the producer doesn't know and doesn't care who's listening. They just fire off a notification and job done. The not so good here is what we've seen previously is we start creating coupling between our services. And if that's something we designed for and we're aware of, then that's fine. But if it's something that kind of goes under the radar or we're not conscious of that, it can actually start to cause problems. And like you also have like less resilient systems. So what happens if the user service went down in this example? All our downstream services, all our downstream consumers would break, right? And the most important thing with Amazon EventBridge, I think, here at the bottom there is event filtering is poor. Now, this is for me one of the best features I find with EventBridge is the ability to filter on targets. So when an event comes in, where do we want this to go? In what situation do we want this to go to a different target? Now, if we have a notification event here, there is quite minimal we can actually do with filtering downstream. So that's something to consider. So let's take a step back. And what happens if we were to make changes to the event? So instead of being a notification event, what if we added more data to the event, and how would that change our system? So here we have the same event on the bottom right, and you can see we have information about the order, and we have information about the user, right? And if you imagine a real system, you might have more information about the order in there, or more information about the user, or whatever. So the good thing about this is when we go into the invoice service this time, the invoice service doesn't have to talk to other services to be able to do its job. The data is already there in the event, and then it's autonomous. It can actually do what it needs to do without talking to too many kind of third-party systems, which is great. And also the way I kind of like to think about this in my head is having this kind of service as like its pure function, right? Where it's given the event that goes in, it'll always produce the same kind of output. When we start having different services involved, it's harder to kind of test that kind of model, I believe. But as we go through this again, and the product owner says, okay, we need to send an email when the order is created. So we create the email service. But this time, the email service does not need to talk to downstream services because the information is already there. On the left, I have the email address, I have the first name, I have the amount, I have the ID of the order. I might have more information about the order there. So I can start picturing that and presenting that to the users. And then as we go through, we add more and more. And then, rather than having all these kind of coupling this time, we actually, there's a high chance that we might not have that coupling, right? And that all that comes down to is the detail, is the event detail itself, right? Is actually thinking about what goes into our events and the impact of that. And what I'm talking about here is a pattern called the event carried state transfer pattern. Again, you'll see this online called the fat or thin event, right? And the idea here is you put more information into your events, right? You carry the state in your events, and there are different ways you can do that. I've seen events online where you have the whole somehow you can have the whole historical information about the order in the event, or the delta, right? If the order has changed amounts, what has it changed from, and what has it changed to, and all that information can be there. So the good thing about this kind of pattern is, as I said earlier, that the services become autonomous, right? And in ways you can get away with the event kind of doing the job that it needs to do. We have like more resilience because we have like less dependencies, right? Downstream. We don't have to go out and get information. We can kind of do it all within. Another key bit there at the top there is kind of better event filtering. So now imagine if this event is flying through EventBridge, what we can do with it, what kind of event filtering can we do with that, what different targets, and all that kind of stuff, which I'm going to go through in a minute. The not so good parts to consider though are the contracts. I believe are an important thing to consider. So as this event grows, or if you imagine this event was like triple in size, and for whatever reason the order service decides to take out the delivery address, what downstream services are you going to affect? Who are you going to break? Because the thing that we're taught in event architectures, is the producer doesn't care about the consumer, right? You can just produce events and consumers just consume them if they want, which is a double-edged sword, I believe. Another problem here is also another big problem is stale data and replicated data. So if your downstream services, if your consumer got this information and stored it in a local cache, for example, or a local DynamoDB table for whatever reason, now where's the source of truth for this data? You've got it in this service and you've got it elsewhere, right? So that's something to consider. The source of truth. And also with stale data, what happens if a downstream or a consumer failed and we replayed this event 3 days time, or 3 hours time, or 2 hours time? Is this amount of this order still correct? Is the user's first name or email address still correct? These are things you got to kind of consider. And then down at the bottom, something really, another thing we got to consider with all this information flying around is PII information. Should a consumer know about the user? Should the consumer have access to an email address, right? All these kind of things to think about. And what I'm getting at here is we can spend a lot of time thinking about our architectures and think about when we raise events, how we raise events, our Lambda functions, Dynamo table, everything, and like, you know, all these services. We spend a lot of time designing stuff and a lot of time building stuff. But maybe, you know, not maybe some of us, I don't know, I definitely fell into this box, not enough time thinking about the event design itself. Because again, as I was saying here, the event, I believe anyway, the event design has an impact on our architecture, I think, whether we like it or not. So when we talk about event patterns, there are other different types of event patterns that you might see online, like domain events or events versus commands, which I'm not going to go into today. But there are different kind of events that you can kind of explore online. So the carried state transfer we just spoke about, in the middle, we have a delta event where you can see the previous order and the new order. You know, you can start to say, okay, what has just changed in the event, and let downstream services just already have that information to kind of do whatever they need to do. Top right, you've got the simple notification event. Something happened, something somewhere happened, which is good in some use cases. And then down in the bottom right, why couldn't you have a hybrid of the both? Why couldn't you send the order ID and always send the user in the example there? So it's just thinking about these kind of events. And when I think about this stuff, I kind of, as I was putting these slides together, I thought, what would I use with Amazon EventBridge? And I kind of alluded to it earlier, but more I think about it and my events, I would personally probably lean towards more of a kind of an event carried state transfer event, right? A bigger event. And the reason why I think I do that with EventBridge is just to get these kind of features that are available to you. So the filtering and the rules, right? So on the top line, we have all orders going to a target. Let's say the target was a Lambda function. So every single order goes there. That's simple. We can do that. The bit in the middle, all orders over £50 or 50, whatever that means, can go to another target. And maybe that target needs to get information, real-time information, so it goes and talks to the user service. There's nothing wrong with that. It has the user, but maybe for some reason it needs to make sure it gets the latest user information. But we have the option. The key there is we have the option to do that, because we're not forcing, with a notification event, you are forcing downstream services to get the information. With this event, you know, they have the option to either read what's there or get the information that they need. And then down at the bottom, again, we can transform data, right? So maybe this event come in with the order and the user in the detail there. But maybe we have a downstream service or a target that just really cares about the user data for whatever reason. So we can like transform that, pull that off, and just pump it into there. So I think, you know, this is a core, for me anyway, this is a core concept of EventBridge and the whole serverless stuff. And, you know, the ability to kind of have this scalable event bus where we can just fire events off and be able to create some targets using some filters. This is one of the core functionality, I believe. So the question is, you know, what can help you? What can help you with event design? I started thinking about that for the audience. And this is the kind of thing, some things here that might kind of help you. The first thing I want to talk about quickly on the right there is event storming. And if you're not familiar with it, event storming is a kind of process that you can run with people in your organization. Now, the key is it's not just technical people, it's everyone in your organization, right? And you talk about the behavior of your system, and you start to define your context. You start to define your systems and your bounded context, right? And you start to define your events. And what you'll see is this natural flow of your system going from, you know, when the user starts all the way to when the user ends in your system. And you start to have these events emerge. And what I've done in the past too is go further into these events. So let's say that we create this order created event. Let's start talking about the schema, right? Is it too early to talk about the schema? I personally don't think so. Let's start talking about what goes into this event, right? And what else can help you on the screen? There's tons of different kind of event naming and terminology. But I would go read about event carried state transferred. Event sourcing is another one, where we kind of store all the event information. We replay that back to get the current state of our data. domain events. The typical one bottom left is event versus command. What is a command? What is an event? And notification event. So what I would recommend is just being conscious of all that. Be conscious of your event designs and just go kind of read and research out there. There is a lot of information out there, which I'll share some resources in a minute. And this is the key thing, right? This is kind of controversial thing, but we get taught that producers don't know about consumers in event architectures, right? And this is the whole kind of nugget, the golden nugget, that producers fire events and consumers can just consume this stuff in this, this beautiful world and do their thing. And this is the power of event architectures. And we start creating decoupled systems and resilient systems. But often when you talk to people, you will find a common problem with events, which is that someone needs to know about the events, right? And the producers and the consumers. Like the order service, for example, does not need to care about who's consuming this event. But the people building this architecture, I believe, or someone somewhere needs to know how this architecture fits together, who is consuming what event. And I've heard like stories with large organizations that they don't know what events they have. They don't know what consumers are consuming events. So they start to worry about all that kind of stuff. So that's something kind of to consider there. And yesterday I was just watching this keynote again, right, by Werner in reInvent 2021. And there was just like 15 years of APIs. And there was one thing in particular on this that kind of I started thinking about and kind of considering is when we design our events. So this whole thing here I've circled is work backwards from your customer's use case. And he was talking about API design, work backwards from your customers from an API design. But why can't, in event architectures and EventBridge, for example, why can't we work backwards from a consumer point of view? Now, the hard thing there is we don't know who our consumers are because our consumers evolve over time. But realistically, you probably know who one or two consumers will be of this event. So why couldn't we push the responsibility onto the consumer to define the payload of the event? And then they wouldn't need to go do all these service calls and everything else. But that's just something to consider. And I'd be interested to see what everyone else thinks about that. But the one thing from this short talk, I kind of want to take away here is just be conscious of your event design. When I started off with EventBridge, as I said earlier, I wasn't conscious of the event design at all. It was kind of like, what do we put in the event? Oh, I don't know, some useful information. Yeah, sure. What's useful? The order ID and maybe some amount stuff. Okay. And then downstream service says, thank you very much. And if you're lucky, you can probably negotiate a contract there, or the downstream service just says, okay, thank you very much. I'll do my best with this information and go and make more kind of requests and create more coupling in your architecture. So the summary of that really is kind of, when you think about event design, just think about your events up front. Think about events first. And I think it will really help you along down the road. Think about like notification events, event carried state transfer, read about them, understand them. I think they'll really help out when designing these architectures. And another thing, as I just mentioned, consumer first. This is a question, to this community, should we be pushing on our consumers of our events to define the payloads themselves? And again, I'd be interested to hear what other people do there. In the top right, understand your domain and bounded context and behaviors of systems can really help with that event design. And in the bottom left, there's even more. There's events and commands and domain events and event sourcing and loads of other things to consider. But with Amazon EventBridge, as I said earlier, my favorite part of it really is the kind of event filtering and the transformers that we were able to do. So if our event payloads are big, and I would personally push for bigger than smaller, we start to see all that kind of information, start to see all them benefits that we can do with the targets and the rules there. So I kind of want to finish there. I hope that was useful, and there are some kind of extra resources, and I'll share this online on Twitter afterwards if you're interested. But in the top left, we have event storming. So if you want to know more about event storming, there's tons of resources. That's a good place to start. I've created a repo, a welcome contributions called Awesome EventBridge. So if you want to know more about EventBridge, want to dive into like loads of different patterns and talks and deep dive into loads of content that the community has built, Awesome EventBridge is somewhere you can go for that. Excuse me. Another great piece by Martin Fowler is The Many Meanings of Event-Driven Architecture, where he talks about the different types of events, and I believe they relate definitely to, and they can relate definitely to EventBridge there. Another YouTube channel to shout out there is Code Opinion. If you've not followed that, go check that out. I quite like the content there. It's very kind of high level about event architectures, and I think there's a lot we can take there, take the learnings from there and put it into EventBridge when we're working with it. And just a kind of a couple of shameless plugs there. At the bottom is one of my open source projects I have at the moment. If you are interested in documenting or exploring your events using Markdown files and getting kind of getting graphs and all sorts of stuff, check out Eventcatalog Dev, which is an open source project that I've got that works with EventBridge that lets you document things to the next level. And then on the right here is just the latest blog post that I've done, which is talking about event payload standards. So taking it to the next level is once you've defined your payloads, what are the kind of standards of what people are doing? And this is kind of all coined really from Sheen's work and Lego's work, where they share, luckily for us, they're sharing that the metadata and the data of the detail there. Just check that out. There's some good content in there. And I think what I found is a lot of the EventBridge, a lot of the Amazon EventBridge community are starting to conform to that kind of payload standard. So check all that out, and I hope you enjoyed the talk. Hope you found it useful. I'd love to know kind of what you think. If you've got any questions, kind of tweet out, or if you kind of got any objections or thoughts, I'd love to hear it all. So yeah, thank you very much.
Well, that was fantastic, Dave. So much content. If only there was some kind of EventBridge guide or something that was available. So I'm sure we'll come and touch on some of these things later. But all of these questions around choreography versus orchestration and the importance of event design and modeling and so on. So these are things, like I say, we'll I'm sure we'll touch on them later. There's been some great questions already dropping in the chat. But what we're going to do is we're going to go through all the talks first, and then we'll give all the presenters a chance to give their input into the questions. So now with that, I'm delighted to bring up Luke to give his talk around EventBridge self-service mission-critical event bus. So over to you, Luke.
All right, thanks, Matt. And thanks, Dave, for your first talk. You had a lot of topics that I actually also will be touching on, but really in a more of enterprise context, because topics like PII, personally identifiable information, and event contracts, but also data ownership, like who owns data and who's responsible for it, are really big topics at PostNL in an enterprise context. So today I want to talk about the PostNL use case for EventBridge. And that is EventBridge as a self-service, mission-critical event bus. So PostNL is the Dutch Postal Service. We're actually a bit larger than only the Dutch Postal Service. We cover the Benelux. And on average, we deliver 8 million letters per day. But we also transfer 1.2 million parcels per day. And that's really the future of our business as well. So those parcels generally include the logistics for web shops, both large and small. So anytime anybody in the Benelux orders a parcel from somewhere, there's a big chance that we deliver it to your doorstep. And to get these parcels from where they are to where they need to be, many processes need to align. And that includes pickups from where the parcel is, and that is also called the first mile. Then the logistics between distribution centers, the sorting in the distribution centers themselves, and then the delivery to customers, which is called the last mile. And each of those processes is controlled by one or more applications, and they are largely built and maintained by our in-house development teams. And of course, we also have applications for BI and analytics, and they really want to receive data from all of these applications. So we're really sending many events between many applications. So quick 2 examples of what those events might look like. Here on the left, you see a parcel being registered. So that's some a customer delivering a parcel in one of our retail locations, and that generates an event. The event goes onto our centralized event broker, and it gets routed to the delivery planner application. That determines where the parcel should go. It's part of the event, so it's contained in the event. And then it generates a delivery plan. And that's also an event, goes back onto the event broker, but this time it's routed to the collection application, the sorting application, the deliver application. Another example, in our distribution centers, we might have observations. So the parcel goes onto a sorting line, and as it moves down the sorting line, we have cameras that register all the parcels moving down the conveyor belts. And anytime they detect a parcel, that's an observation. And every observation is an event that goes to the event broker, that sends it to the sorting controller, and the sorting controller decides on the next junction, should the parcel go left or right. And it sends those events back to the event broker, and that routes it back to the distribution center, but also to other applications, such as the logistics planning applications that control the trucks. So we have many producers, and we have even more consumers of events going over this central event broker. And when I joined PostNL about a year ago, setting up the integrations between producing applications and consuming applications was a manual process. So an application or 2 applications that wanted to exchange events had to create a ticket in our ticketing system, defining who would be sending the event, the format of the event, maybe any transformations that might need to happen, and who would need to receive that event, and at what endpoint they would like to receive it. So it's really, well, we had a lot of automations, but still a manual process. And the new paradigm that we're introducing at PostNL is self-service. And it has a number of goals, but one of the primary reasons to do this is really to get the integration team out of the loop for building new features. So we're really taking a sort of DevOps approach to events in our architecture, where the producing application is responsible for the events that they send, and to define the schema of that event, and then to tell in the self-service portal the event broker what event they will be publishing. So when they publish events, they are no longer dependent on us as an integration team to register that event. They can really do it themselves. And from the consumer side, it's the same. They can just see all the events, discover all the events that are on the event broker, choose what to receive, and subscribe to them and receive them. So they are independent as well. And the other big topic that we try to achieve with self-service is we try to reduce friction for innovation. So let's say a team has an idea for a new feature or a new application or a new concept. They should simply be able to see which events are available to power that feature and subscribe to that feature, build their proof of concept, see if it works. If it doesn't work, they can just delete their subscription again. If it does work, they can productionize the proof of concept. And in a self-service portal, there's really low friction for that goal. Well, if you would have to create a ticket and describe exactly your use case and exactly the events that you want to receive and where you want to receive them, that will really slow down that innovation. So those are the two main goals for self-service. So really, we're focusing on both the producer and the consumer. For the producer, they should be able to self-sufficiently register their events and the events schemas. So the definition of the events that they will be sending. Those will be put in an event schema registry, which is simply a list of all the events and their schemas that are available. And then consumers can look at that registry, select the events that they want to receive, and create a subscription for those events, sending them to the location where they want to receive them. So that's the easy part, you might say. But in our mission-critical, sensitive enterprise environment, there are a few other aspects to keep in mind. And one, and that's really what David was touching on as well, is event validation or event stability. Because if a producer is sending events and the consumer expects that exact format and builds their application around it, and then the producer suddenly decides, hey, I'm going to change this schema and I'm going to remove some fields because I don't think they're necessary anymore, but the consumer is relying on them, then the consumer will break. So we really need mechanisms to guarantee that the events being sent follow that schema. And the other big issue is that a number of the events that we send might contain personally identifiable information. So addresses are, of course, a common one, but also phone numbers or maybe even bank accounts. And in a self-service portal, you really don't want to get to a situation where you're sending PII events, and somebody in some team says, hey, this is really interesting. I really like all this credit card or bank account information. Let me just set up a subscription to receive all those events and write them to a S3 bucket that I personally own. You absolutely want to avoid that. So to protect against that, we have a mechanism where the producer marks an event as either sensitive or not. And if it's sensitive and a consumer wants to receive it, they don't immediately create a subscription. They create a request for that subscription. And that goes back to the producer. And the producer has to approve it first before the events start to stream towards that subscription. And then the subscription is immutable. So you can't, once it has been approved, you can't change its endpoint, you can't change the events it's receiving without again going through the validation process. But those features, so the event validation and the subscription confirmation, are not natively supported by EventBridge. So we had to come up with custom components, custom solutions to make that work. And in a high-level overview that looks a bit like this, we have a number of services working together. On the top, you see our graphical user interface. So that's really a thin layer. That's just a website, the interface for our producers and consumers. We built it in Mendix. And that communicates with an API. And the API is the management service. And the management service is really responsible for all the business logic and the authorization and authentication of the users. We have Cognito in there, and it integrates with our single sign-on. But the most important part are the business rules. So when a producer generates a new event, that's fine, just go for it. If they want to update the event, we check if it's not a breaking change. If it's a breaking change, we reject the update. Subscribers use this API to create their subscriptions. And again, that's where the business logic is, which says, okay, if you want to this subscription, somebody needs to confirm it first. But when your request, either to create an event or to update an event or to create a subscription, passes all the business validation rules, the management service generates an event. So this system itself is an event-driven system. And the event goes onto an SQS FIFO queue, and that triggers a step function state machine. The state machine triggers a code build deployment. That actually deploys a CDK project, which deploys the resources, the components needed for this specific producer. And we do the same for the consumer. So this SQS message, both this one and this one, contain the definition of either the producer or the consumer. And that results in certain components being deployed. So let's take a quick look at what those components are. If you deploy a new producer, so you've passed all the business validation, business rule validation, the deployment starts, we deploy a single CloudFormation stack with only 5 resources. And that contains an API gateway model, resource method, and request validator. And the model here is important because that does the event validation. So in combination with the request validator here. And the model really defines what the event should look like. And it simply returns a 400 error if your event does not match that schema. So going back to this slide with the example event, here on the event broker, we have the event validation here on the left. The distribution center sends those events and they match the event. So they're accepted onto the broker and forwarded to wherever. If the producer decides to change their schema, then they will get rejected here at the event broker and they will receive errors. That also means that there is a lot of responsibility in our producers and also a certain maturity level required for them to not suddenly change their events. But by doing this, we can guarantee that whatever the sorting controller receives matches the event as registered in the event schema registry, and they can really build their application around those schemas and really depend on those events always having that format. And this is this is one of those event schemas being deployed to API Gateway. So it's just a JSON schema draft 4 that defines all the fields and which are required and their formats and their optional fields in those events. And this is, again, uploaded by the producer. So this is the responsibility of the producer to define their events so that they match the actual events. Then for the last part, we follow the same process for consumers. So again, SQS message goes into step functions, triggers code build, that triggers a deployment. But this one is a bit bigger. So here you can see we have 19 resources. It's a single stack again, so one stack per consumer. It contains the AWS events rule. So this is the rule being deployed onto EventBridge. And in this case, it has a Lambda function, which is the consumer. And the Lambda function really does the egress to whichever target we want to send this to. And then we have a lot of additional resources. For example, we have an SQS queue, which is used for retry. So if this Lambda function cannot deliver the event, it will put it on the retry queue and retry it for a configured amount of times. And if the event fails to deliver after those retries have passed, we have a DL queue, and the messages get put on there. And of course, we have some CloudWatch alarms here that really trigger when events cannot be delivered or they are retried too often. So those are the producer and consumer parts. As I said, this is an event-driven solution itself. So this is a different diagram for the same services. Again, we have the management UI, business validation that triggers that puts either the producer or the consumer that needs to be deployed onto an SQS FIFO queue. The reason we use a first in, first out queue is to avoid duplicate deployments at the same time of the same stack. So this really prevents that from happening. That triggers the workflow, and that triggers code build with the CDK deployment for those components. The workflow itself looks a bit like this. So this is the step functions design studio layout, and this is an actual deployment in that process. So we validate the SQS message coming in. It's a sort of a defense in-depth mechanism. We check if it's either a create update or delete. In this case, it's create update. So we store the inbound configuration in S3. Then we start code build, which fetches it from S3 again. And when code build is done, we delete the SQS message from the FIFO queue, and the deployment is done. And then the code build container itself, it's actually pretty simple. So we have a CDK project that knows all the components being deployed, but it takes that configuration from SQS to configure those components and really combine that into one stack using the CDK. And this is the CDK deployment of the CloudFormation stack that you just saw before. And as you can see here, it finished in about 84 seconds. So in a minute and a half, the entire set of components deployed for this producer or consumer is available in the production environment. And the results of this solution is that we have achieved a fast self-service solution. So our producers and consumers only have to wait a few minutes for either their event to be registered or their subscription to be registered. And we still have all the requirements needed for the mission critical environment in which we live and work through event validation and the subscription confirmation. And that's it for me. Thank you for your time, and enjoy the next talk.
Thank you very much for that, Luke. I think it's always fascinating when someone lifts the lid on their sort of architecture stack, so the single stack deployments with sort of state machines, API gateway validation, there's also sort of Lambda layers in there. There's a few questions already come in, quite specific, but again, we'll cover those. We'll cover those at the end. So thank you very much for your time there, Luke. We'll bring you in very shortly to answer some of those questions as part of the panel. And with that, I'm delighted to welcome Sheen. So welcome, Sheen. Man. So
Hi.
Really excited to hear what you've got to tell us today about some of the features that Lego use with EventBridge.
Sure. Thanks. Let me just share and we can get going. Let me know.
Perfect.
All right, excellent. Well, okay. Hi, everyone. Thank you so much for joining us today. I mean, I'm more excited because it's EventBridge, one of my favorite services. I probably will go fast to give us enough time for the Q&A. So if someone is new to EventBridge, and if they see this definition, they think, oh, it's kind of boring because they've been through many buses. So our bus, this bus, that bus. So probably we need to come up with a more exciting definition to get people onto EventBridge. But then you show this picture and they say, oh, that sounds interesting, or looks interesting, at least because it's colorful. The fact is, there are many things hidden in this picture than from the definition we saw. First thing is, you see, we have more buses. It's not just one bus. There can be multiple buses as part of the EventBridge architecture. So the default bus is the AWS owned one, and we can create our own custom buses as many as not as many, but many buses as we need. But the interesting thing is we can also, bring in partner event buses for the, third-party partner applications, and then a bunch of producers, and then so many consumers, many AWS services, and also partner services as well. As I covered before, one of the powerful things for EventBridge is the filtering and routing rules. I mean, that is kind of the heart of EventBridge, I would say. Okay, so that's good. What are the core features of EventBridge? So custom event bus I talked about. Event filtering and routing is a real power behind EventBridge. And the fact is that we can have multiple targets. So per rule, you have 5 targets, and then you can have multiple rules and with multiple targets. So event transformation is something really important. I think David touched upon, complying to API contracts and things. That's where the sort of the event transformation power comes in. Now, if you look at some of the cool features or say hot features, for example, the partner event sourcing is a really good one. And talked a lot about schema and the registry, discovery, those kind of aspects. And the event archiving and replay, this is a real power behind EventBridge. This is a kind of a not the the original feature, something came afterwards. And the API destination, another exciting thing which I will touch upon later on. So recently they added the sandbox support to have test the the filter patterns and things before putting into practice. So it's getting better. Okay, so today I'm going to touch upon two things. The first one is the API destination. So I will start off with a customer use case, and then I will show you how a API destination helps in such situations or scenarios. So let's say a customer walks into a retail store, and they want to join the loyalty program, for example. So simple thing, they will get a card or something handed over, and they can start earning points. So that part is done. So that's all we need as the customer joins the loyalty. But the fact is that if when you onboard a customer to a e-commerce platform or a business, you need to set up a proper account. So in this case, that's a different domain looked after by different microservices. So obviously, the loyalty registration part will get the initial details and hand off to the other service, and the other service will start communicating with the customer, emailing, and so they can put the address, contact number, etc., etc., etc. So this is kind of the use case we will go through. So in a traditional way, what we will do is, so we have an enrollment service, simple service, an API gateway, Lambda, and a Dynamo, kind of in simple terms. So traditional mindset, what we'll do is, customer service has an API. Okay, hit the API, call it, invoke it. Everything is synchronization. That's fine. So they will prove that it works within a few milliseconds to get the response. All good, fine. So the problem is, if there is a trouble with the API or the communication, that's when it becomes tricky. So in a retail store, a customer is standing in front of the till. So that's when you see this sort of the difficult smile between the two people. Oh, won't be long, that kind of situation. So this is one reason why we need to think of kind of decoupling these situations. So typically we add a DLQ, obviously, to catch all the errors and have a DLQ handler. Then you need to work out how to, kind of get the DLQ handler, read these things, replay those kind of things, etc., etc. So this is where the power of EventBridge comes in terms of a choreographer. So that really helps to decouple such scenarios, because in this particular situation, there is no need whatsoever why these two services should be communicating synchronously, right? So simple. So an event goes out to the bus and it does some magic, and then it invokes the target. So this is where the API destination comes in. API destination is basically a target rule. So routing rule event comes in, you do the filterings to get the particular event in, then do the transformation, and then hit the target. The target here, as I said, is the API destination. Now, in this case, this transformation, event transformation, is crucial because we are dealing with an API which has a contract. Okay, so these are of the default routing option of the pass-through rule. A pass-through event rule is not going to apply here. So this is why the event transformation plays a crucial role in such situations. Okay, so it's a target, as I mentioned. Okay, so what is it made of? What is this API destination then? Because it's not one of the standard AWS services, right? So it's basically two parts. One is the connection, where the authentication, authorization settings, and the other one is the endpoint. So if you look at the connection, there are three supported options, like the basic auth, the API key, and OAuth. You may be thinking, who uses API key these days? But you'll be surprised. There are so many partners, SaaS applications still rely on API key. They will give you an API key when you open an account for production or sandbox, etc. So that is still there. And on the endpoint side, we have two options where we can hit a custom HTTP endpoint, or we can use partners. The partners is interesting because there's a long list of partners. So especially if you're dealing with the monitoring application, observability, things like that, and if you want to send metrics and stuff, most likely they have an API already there and integrated with API gateway. EventBridge. So that's an easy thing to do. And the custom one is obviously where we supply the endpoint URL, the method, and the invocation rate. That's, again, another important one, because though it's optional, this is really crucial, because more often when we hit the third-party application, there is an SLA, there is a quota, and et cetera, et cetera, et cetera. So it really helps to limit the sort of, inflow of the events or the hits we make. So that really useful one. And basic auth, simple username, password, key, and the OAuth is really useful, and that has the option to supply the OAuth endpoint to get the token and the credentials and things like that. The good thing is that these credentials are maintained in Secrets Manager. So I won't go into details of these things, but this is something really useful because if you know Secrets Manager is not cheap. Each secret costs, I think, 25 or 40 cents per month, and then the API hits are also expensive. But when we use as part of EventBridge, internally, EventBridge uses Secrets Manager. So EventBridge, absorbs the cost, and we don't need to pay anything. So that's the beauty of using the OAuth with the Secret Manager. Not just OAuth, the other ones as well, but using the Secrets Manager behind the scenes. So as I mentioned, the benefits are rate limiting, retry mechanism is built in, and functionless. So there's no function to write. So think about it. If we hit the same thing, an API behind, that is behind an OAuth, we need to kind of, you make sure that the token is not expired. So if the token is expired, you make another call, or you have a kind of, scheduler running often to fetch your token and keep it always available, etc. So all those things now is, abstracted away and kept away, part of the EventBridge. So we don't need to kind of mess around these things. Partner target I mentioned. Things to be aware of: payload size, because no matter how good the API is, and it's only limited to the the event payload size that EventBridge support, because you can't add anything on top. And it's a fire and forget situation. There's no response coming back. So this again, I think we are raised with EventBridge team, because in such situations, if there is a way to receive the response from the API and with some sort of correlation ID, put it back to the bus, that can really open up more use cases for EventBridge. And there is a timer, 5 seconds timeout. So that needs to be mindful of, and the debugging challenge. So I know I mentioned that I won't go through the details of the Secret Manager. So please go through this blog post where I have gone through in detail talking about how to use Secrets Manager and how to set up the connection and the destination, everything in detail. All right, switching on to the next one: archive and replay. So the use case here I will go through is the failure retries. So say for example, typical order processing flow. So you may have an order processing service where it receives the order, it will go through a bunch of validations or discount calculation, so many other things for internal purpose, and there could be a third-party application where you keep the order data, or a different domain within the organization they look after. So there's a microservice. So they need to talk to each other and to send the data. So this is where the EventBridge comes in. So send off the event to the bus, and then it goes to the other service. All done. So everything is good as long as you hit the target and get the 200. Okay, fine, good. The problem is that when things go wrong, okay? And in such situations, the possibilities are that most likely there are two different scenarios, failure scenarios. One is that you're receiving an error because the order submission service is sending wrong data or rubbish data. So no matter how many times we retry, this is not going to go through. So this is like the hard error situation. Whereas things like timeout service unavailability and things like these needs to be retried. So retrying means we don't know when the service is going to become available. So we need to keep hold of the details so that as soon as it become available, we can resend. So this is where the EventBridge archive replay becomes really useful. Okay, so typically we use a DL as I mentioned in the previous use case. So then you need to kind of look at the queue and put the message back. Or the other option we can use is like have a scheduled scan of sort of the order cache. So obviously in this case you follow the sort of storage first pattern. So event comes and stores there and has the status and everything. But it's okay if it's manageable. If it's thousands of orders stack, then you need to then think of the batching the query, because Dynamo has limits and things like that. So that can really then you think of, oh, I should have a state machine here, etc., etc. So all these complexities go away if you have this sort of set up an archive and use it as part of the EventBridge itself. Okay, so if you think of the auto submission service, there are typically three types of events that I can think of. So I mean, there could be many events, but one is success event. So everything is good, 200 okay, it goes success. So the other one is the error. So there could be a third type of a third status basically event which has the retry. Okay, so all it's saying is that okay, I couldn't contact the third party or a SaaS or a API. So the status is you need to be retried. So that's the status. So these events go out from this particular service onto the bus. Now let's get to the event archive mechanism. So those events come to the bus. Okay, so there is a route to any consumer, whoever needs to get hold of the any of these types. That's fine. So that's the normal route. So for us, the archive, we are interested in the retry event. So that goes to a particular rule and gets to the event archive. So that is the event archive. So let's see what event archive is. Basically a collection of events. It's something part of the EventBridge we can set up. So this is basically creating an archive. So we give an archive name and we give a pattern in the sense for those kind of events to be captured and put into the particular archive, and we can say, okay, how long we want to retain this archive. It's internet, or it goes up to 2 billion days. I don't know. You can work out how many years. Probably some 5 million years or something like that. So the event filter pattern is important because this is what filters and looks for that particular event and puts into the archive. So in this case, the status retry is something that we are targeting. So that's all good, but there is a problem with archive and with this pattern because it can get into some kind of cyclic loop, because there can be other event filters and rules available. So that's why when we create an archive with a pattern, AWS internally creates a managed filter pattern. So as you see, there is an extra attribute there, the replay name. So that gets added by this pattern that's maintained by AWS. We can't change this pattern. You'll see why this it makes sense. So what he's saying is that replay name doesn't exist. So it's a kind of it's not coming from the archive. It's a fresh event. So that's the pattern it's kind of keeping. Okay, so that's the event replay. So how do we now, sorry, that was the archive. So how do we replay? So we have events now stuck in the archive. So how do we kind of, bring them back to life? So in this case, you may have some kind of, cron job scheduler looking at the status of the, SaaS platform, for example. So it's kind of, adding the status to a Dynamo table or somewhere. It keeps track of, okay, when was the last time it was up, when was down, and then how long it was down, etc., etc. Depends on how we keep the data. So there is an event stream going out. There is a Lambda function looking for the change of status. As soon as it finds that okay, it was down, now it's up, it will kick off the replay via an API. So that will kind of put the events back to the bus, and it will probably go back to the same service and kind of start the cycle again. Now, the API is very simple. All you need is you need to supply a replay name and the start and end time. So when do we want to start playing the event and the end? So that's based on when those events were put into the archive. Now, when we get a replayed event from the archive, the replay name I mentioned earlier on, so that gets added. So this is really useful when it comes to setting up the filter conditions to target that particular event. So this is the sort of a filter pattern. You can say that, okay, now I'm interested in this particular prefix or replay. The reason why I favor this sort of naming pattern is that we can set up different archives as needed. So if you look at the benefits, we can set up multiple archives for aiming at a different rules. So never put one archive and everything there. That can become a nightmare. Of course, you can use that, but try and keep separate archives, taking advantage of serverless granularity. So that really gives more control, and we know exactly which archive is getting replayed, the event, which one is coming from, etc., etc. So the other ones we talked about, things to be aware of. When you start replaying, currently there is no way we can tell EventBridge that kind of rate it like this, few events per second and things like that. So it's kind of an exodus. So we need to be careful, especially if you're talking to if it's going to a third party or other application may have sort of the quota limits and things like that. So that needs to be mindful of. And the order is not maintained. So as probably that EventBridge doesn't guarantees the order. So that's the same true. You don't get the order in which the events went to the archive. So it could be different. Idempotency, there could be events hitting again and again. So the services should take care of those things, and we don't get to control the archive. So that's it's not a big deal. Again, more details. I have this blog post where I go through in detail. Actually adding the circuit breaker pattern here more in detail of what I just briefly mentioned there. And I have a bunch of blog posts talking about EventBridge a lot. So if you're interested, if you want to learn, so you can identify from here. So that's for today. Let's go build serverless. Thank you.
Awesome. Thank you very much there, Sheen. It's like it's amazing, just like the content that's being shared over the over the course of this sort of last hour or so. So conscious of time, what we're going to do is there's been a number of questions coming in. We don't have an agreed format, so it's basically just if you feel you've got something to contribute to the answer, just shout out and jump in. There's a question that came in early, which was on Twitter, which is basically asking around, I guess it's more, are there any concerns in terms of extra latency adding an EventBridge as opposed to potentially tightly coupling a producer or a consumer and a producer?
I'll make a start, and David will pitch in. So I come from as part of the Lego group, I'm part of the team behind Lego.com. Okay, so we are talking about customer-facing website. And we have EventBridge in place behind in many places. There isn't noticeable latency or anything. I mean, I know I haven't touched upon. I have a blog post written where I talk about how the orchestration with step functions and choreography with the EventBridge work together using the task tokens. Those two services I mentioned, order processing and the order submission thingy. So we have a huge state machine behind the order processing and uses task token to go to EventBridge, to the other service, submits to the third party, comes back to the bus, and then kicks off the flow again. So usually when we look at a particular order submission, as soon as the order is a few milliseconds, a second maximum, everything is there. There can be odd situations that there's a latency, but it's something I never noticed, and there shouldn't be a concern at all.
I have something to add there because actually, by coincidence, we did performance testing on our EventBridge solution this week. So I got some hard numbers. So in our case, it's like API gateway, then a Lambda function, then EventBridge, and then another Lambda. That's the process. And if we measure across that track with millions of events, then the average is 800 milliseconds. So we see that, well, publishing, you have outliers, by the way. You have outliers up to 20 seconds, and order is not guaranteed, as Sheen also said. So those are things to keep in mind. But the average is under 1 second. And we really communicate to our users that that's the latency that they should expect and that they should use or design for. If they have lower latency solutions, SNS is actually not a solution because it also has like half a second latency. So you're really looking either at Kinesis or some other streaming solution like Kafka, but that's of course not serverless.
Yeah, I've got just a quick one to mention on that. You kind of mentioned also to design for, and I think things I've found in the past with latency issues and kind of event architectures in general too, is even to the customer's expectations. I think the way you actually build applications and build interfaces and everything else like that can change or sometimes has to change. So I give you an example, right? You think about just like, for example, like Just Eat, right? When you order your food and everything else and your delivery's on the way and they're waiting for them to do something, you can tell it's an asynchronous model because it's an asynchronous UI. And there's that to consider too when you're building interfaces. So if a round trip of 800 milliseconds is too long for your customers, then consider what else you can do maybe upfront to help your customers, right? Give them information that you're actually processing something, you're doing something, rather than just waiting around for half a second, 800 seconds doing nothing. So I think there's also that pattern.
Yeah, I think there's quite a famous quote from, I want to say Tim Bray. I think he was the AWS Distinguished Engineer. I think he may even have worked on EventBridge, but I see it on some of these event-driven architecture talks. I think he was sort of saying that in any modern distributed system, if you've architected something where there isn't a queue, so there isn't some kind of decoupling, then there's a bug, which I always thought was it was probably quite true. So next question. I know Dave, you talked about, I think you talked about sensitive data or PI data. Luke definitely touched on it. Is there a way that you handle this sort of sensitive data? Do you handle it using sort of encryption? Is it natively supported?
Luke, you tweeted about this the other day, didn't you?
Yeah. So it's actually been a topic I've been working on, I think a week or 2 weeks ago. There's no native support. So the entire event is going to be readable for any receiver. So if you want to encrypt data and make sure that only the recipients that you choose can decrypt it, then you're going to do synchronous KMS encryption on a field level. So for example, you have the event field A, B, C, D. You choose field D because that's the sensitive one. You encrypt the value with KMS. Then you send the event onto EventBridge, and then the receiver can decrypt that value, but only if you have given it access IAM permissions to that KMS key that encrypted it. And that's the way we protect really sensitive data on EventBridge right now.
Yeah, that's probably quite a nice pattern. There's another interesting question now, which is, I guess it's always going to come up in terms of the where you have long-lived architecture services, versioning of events. Do you have any strategies that you adopt?
I'm guessing the self-service pattern would work here, right?
Yeah. So what we're doing is, we're enforcing that. Breaking changes are blocked. You must release a new version as a producer. So if you're doing that, then you're responsible for publishing both version 1 and 2, or whichever versions you have, at the same time. And to support this pattern, we provide insights into who your consumers are. So also not natively supported by EventBridge, but we record it through CloudWatch logs. And then we can query those logs and then tell a producer, these are the people that are still using your V1. So talk to them to migrate to V2. And only when all consumers are gone, can you deprecate V1. That's the deal.
Yes, something I noticed maybe a month or so ago, a pattern where, the metadata data split. So that the pattern I saw was in the metadata, they carried a version attribute. So that I think is another way that we can, really make it easy for the consumers so they can set up a fit pattern and things like that.
Mhm.
Cool. The next one was just a comment. I think it was linked to Dave's talk. Again, when we started talking about some of the things around event storming, event sourcing, it lends itself to the world of domain-driven design and coming up with your sort of bounded context first, and that can be where you'd have your sort of orchestration within your bounded context, and you can use sort of choreography outside of that. So next question. A video from AWS called The Closed Loop describes a poll model for Kubernetes, stating it's more resilient for distributed systems. How does that fit against an event model, which is push-based?
It's true in ways. A poll model is more resilient because the consumer determines the speed at which they read. And if they are down for some reason, they can just start reading back from where they left off, regardless of how long they've been down. So that's true. But you're putting a sort of requirement on consumers that they need to talk the language of the poll model. For example, Kafka or Kinesis. Now you must read Kafka or you must read Kinesis. While in a push model, you can talk the language of the consumer. So if you want to receive it on SNS or SQS or HTTP or EventBridge or whatever, we can just push it in that format your way. It's a design decision, like everything else, I guess.
Yeah. So the next question, I mean, it was interesting then because obviously Sheen started talking about archive replay, event replay, and so on. But I think this was linked to some of the things around sort of self-service. And how do you set up replay scenarios? For example, a consumer team wants to build a new feature but needs events, needs historic events. Is there a
the question is aimed at me, but maybe Sheen, you talked about replay.
Yeah, I think Christian's. So the tricky part is, unless you set up an archive, you don't have that event. It's just gone. Okay, so you need to plan from that point onwards. So you need to know that there will be requirements, more consumers will be coming on board, and so that's how it works. Otherwise, you can't go back and retrieve a past event.
I guess, yeah. I guess one way you could do that, and one way it might be worth exploring, although I'm not sure, is kind of like event stores. Because some people store the events, so you could store the events for whatever reason. But again, why would you just store events so you could test something in the future? It would be pretty difficult there. But
yeah, I know that pattern. Before they introduced the archive replay, I think the pattern is like have a common, rule and take everything to an S3 bucket and keep it there. But that even with the archive replay, it's not that flexible. That covers all scenarios, but something there.
Yeah, two things I've seen is a standard pattern with EventBridge is having a Kinesis Firehouse consumer that receives all events or a selection of events, if that's what you want, and then batches them to S3. And that is really powerful because then you can query the events with Athena. And there are definitely use cases for that. But that's not really for replay. That's really for event, readable event archive. Because one of the big downsides from the normal event archive, the native one for EventBridge, is that you cannot see what is in there.
Yeah, we used that pattern previously in terms of the sort of fire hose to S3, which is purely for, it was almost like for sort of audit purposes in terms of capturing sort of log data, stream it out to S3 as a long-term persistent storage. And like you say, you can run things like Athena on the top of it to query. So, again, it's a useful pattern for a particular use case. This was a very specific one about the event consumer approval. I think you touched on that you built that aren't sort of supported by the native AWS service.
Yeah, so I'm actually in regular touch with the EventBridge team. They really like what we're doing and they like to learn from it. So that's very AWS-y of them, of course. But for this specific solution, I think this is really the AWS building blocks approach, right? So they give you all the building blocks that you can use to build your own solutions. But if you want something specific like this, you're probably building it yourself. I haven't heard them say anything about this being a standard toolkit solution.
I think, yeah, from what I understand, from what I've just seen, and I've seen previous talks, Luke, around validation of events and things like that. I think there's a huge need for that. A huge need for understanding what you've built it yourself, understanding who's consuming the events, who's producing events, because it becomes a nightmare. You could get to the point where, as you said, you can easily make breaking changes. And with EventBridge, you can version your events just literally by adding a property on, and no one's stopping you, right? So
things like serverless, the serverless well-architected lens calls out doing things like, schema validation at the front, so you protect the data that's coming in. So this is one that you could take it, it's slightly outside the context the question was asked in terms of, before the introduction of EventBridge, how would you build these types of systems? What did these sort of systems looked at before you could put an event bus in place?
In my normal EventBridge talk, I used to have a couple of slides where I show exactly this. So one option used to be have SNS topics. So the problem used to be like for every different event type, you end up creating as many SNS topics, and it's kind of a complete chaos. Whereas with EventBridge, it's kind of streamlined. So you have a clear separation of your microservices, and there's somebody to look after the events and route them, and it gives so much sort of flexibility, especially when we build microservices and serverless, which are kind of granular and small.
Yeah, and in general, I think the pattern or the architecture used for the last decades before EventBridge is the enterprise service bus, which is sort of the same, but the responsibilities are different. So this is really, EventBridge is really, and SNS as well, is really just event as it is, from source to destination. And enterprise services buses are really looking at transformations and lots of manual definitions on that bus. Plus, well, it's not serverless generally, so you have to do some scaling and instances and everything.
Cool. So two questions left. So hopefully we'll fit them both in. An interesting one now around things like observability. But how do you handle tracing with EventBridge? In terms of passing things like a trace ID across with the propagation.
Yeah, so EventBridge supports X-ray. So if you turn it on, you can view a sample of your events in the X-ray console, and you can see how they got there. But X-ray is super AWS specific and also super service specific. So if you use one service in your flow that does not do X-ray, then you're pretty much out of luck. And it's pretty expensive, especially at scale. So the solution that we came up with is if we followed the metadata and data pattern that Sheen, I think, introduced a while back. I've seen it in all of our slides, so everybody's using it now. And we put a correlation ID in the metadata. And we have the schema validation, so we make that mandatory. And then we can really use that ID through the entire lifecycle of the event.
Cool.
Yeah. I think something on there, something I've been thinking about a lot recently is also too, is I think someone mentioned it earlier with like Athena and event stores, but I kind of like the picture of imagine a tool where you had kind of all your events at disposal, but you can kind of like click in on these correlation IDs and see this history of events on a UI and dive into that history, but not just only on correlation IDs, but like user IDs. About any kind of data that you want that you could kind of query across all these events. I think that'd be quite powerful, but that's just a thought.
We want that too, but we will be using Splunk for it. So it's going to be super expensive, but it's going to achieve that goal. Exactly.
Yeah. And then finally, just a nice simple one to end on. Can you share best practice on using EventBridge in a multi-account architecture? You know, things like a central account bus to bus, hub and spoke, something else. You know, I guess this is where it all fits into the sort of the AWS best practice in terms of, you know, the sort of using account separation as an isolation level on things like, you know, IAM, billing, permissions, so on. So, you know, with most enterprises now ending up with multi-account architectures, what does that mean with EventBridge?
Yeah, I mean, I'll make a start. This is kind of a debatable topic because, say, for example, in my experience, when you have multiple different domains and not everyone is on AWS, not everyone is on cloud, so when you are into that mix, probably the APIs become dominant than even sharing between these domains and accounts and things. So even there may be policies that use, APIs. And so that's one thing. The other thing is not every enterprise or not every kind of teams operate with a single, dominating bus. They may have multiple event buses and stuff. So that's why I said it's kind of debatable. Again, when it comes to account, so then you need to know who the subscribing account or the target, etc. I don't know, Luke, do you have this sort of multiple?
Yeah, so I think this question is really the famous answer is it depends. It depends on your use case, your architecture, your requirements, and everything. I just put a message in the private chat. Maybe Matt, you can share it on in the public chat. But that's a link to a reInvent video from 2020 by Stephen Ledick, who really outlines the different multi-account scenarios and their benefits. So I really suggest you take a look at that. It's another half hour. It's a too complex question for us to answer right now.
Oh, perfect. So that we're up on time. The time's absolutely just flown by. So that, obviously a huge thank you to Jim and Mobilize for sponsoring the user group for the certification voucher giveaway. And then a huge thank you to Dave, to Luke, to Sheen. If you go on the meetup page, we've given links to all of their sort of social media and some of the things that they're working on. They're all prolific bloggers and committers back to the community. So please follow them on Twitter, get in touch with them. It seems like there's a real vibrant, growing community that's out there around EventBridge. And so thank you everyone for watching, and hopefully we'll see you all soon. Take care.